Good evening, viewers. And today in chemistry, we are continuing organic chemistry. So, last time when we looked at organic chemistry, we looked at the definition and the terminologies, or should I say terms, that are used in organic chemistry. So today we continue our topic by looking at alkanes. So now, alkanes are also known as saturated hydrocarbons. When we look at alkanes, they're the first hydrocarbons in organic chemistry. Now, these hydrocarbons, they are known as saturated hydrocarbons. Now, you might be asked a question as to why are they called saturated hydrocarbon? So this is the reason that you give them, reason as to why they are called saturated hydrocarbons. Because they have the maximum number of hydrogen atoms. We say alkanes are saturated because they have the maximum numbers of hydrogen carbon. And now we are going to understand when we start drawing their structures. Now as we continue, another common question under alkanes that is asked, they ask about their general formula. Now let us write the general formula for alkanes. So now, when you are asked to display or write the general formula for alkanes, this is the general formula: CnH2n plus 2. When you look at the C represents carbon. Then as for N, it's the number of carbon atoms. N represents the number of carbon atoms. H, it's hydrogen. Then 2, it's a number that's part of the formula. So I prefer you know the formula, which is CnH2n plus 2. Now, this is the general formula where we have CnH2n plus 2. Now, when it comes to bond, you can be asked, what is the bond for all alkanes? So, alkanes consists of a single bond, which is carbon to carbon bond. So alkanes consist of a single bond, which is a carbon to carbon single bond. So when you have been asked about the bond that is in alkanes, it's carbon to carbon single bond. Now learners, let us look at these examples of alkanes. Let us look at the examples of alkanes, learners. Now we are looking at the examples of alkanes. Just from drawing the structures, so when looking at the examples of alkanes, we're going to look at alkanes and list them in a chronological order, starting from the first one to the last one. So the first alkane that we have is methane. Methane is our first alkane. Now, when you look at meth means one. And we have ANE, which represents that methane, it's a compound that belongs to alkanes. So all alkanes, they end with ANE. Now, you can be asked to draw the structure or write the general formula for all alkanes. Now, how can you know the formula for methane? When writing the formula for methane, it is when now we are going to use our general formula, which is CnH2n plus 2. Now, many of you might be wondering or might be confused on how we are going to use this N. What is the purpose of us using this N? So N here represents the number of what? The number of carbon atoms present in a compound. When you look at methane, methane is the first alkane. So since it being the first alkane, the value of N will represent 1. Following the number of compound, since it is methane or number 1, the value of N will represent 1. So it means that when calculating where there's N, I'll be adding a 1. So it will carbon, where there's N, I'll add 1. To where there's N, I'll add 1 again, plus 2. Now when it's like this, I'll say C times 1, which is 1 carbon atom. Then I have hydrogen. 2 times 1, it's 2, plus 2, it becomes 4. So this is the molecular formula for methane. Now, how do we draw the structure for methane? Or how are we going to draw the structure of methane? You can see that methane has 1 carbon atom. So due to space, let me write the structure here. Now, from the structure, we can see that methane has 1 carbon atom and 4 hydrogen carbons. So I'm going to add the first carbon that methane has. And this carbon has been bonded to 4 hydrogen atoms. I'm going to add 1, 2, 3, 4. There. That's the structure. I've drawn the structure for methane. So this is the structure that you can be asked to draw during the exam. I'm going to do 4 more examples so that you understand, learners. So don't forget, when solving alkanes or any question under organic chemistry, you must know the first compound that is on the first one until the 10th one. You must know them individually. So the first one was methane. Our second compound is ethane. You can see that all the compounds under alkanes are ending with A-N-E. So our second compound is ethane. Now, since ethane is our second compound, it means that the value of N on our general formula is going to represent 2. Since ethane is the second compound, the value of N will be 2. I'll say my carbon atom, I'll add 2. Because of the ethane, which is number 2, now I have hydrogen 2 multiplied by 2, which is coming from the value of ethane on number 2. I'm going to add with a 2, following the general formula. So I have C2, here it will be 2 times 2, 4, 4 plus 2, 6. So this is the molecular formula for ethane. Now from the molecular formula, they can ask you to calculate, or they can ask you to draw a displayed structure of ethane. When we look at ethane, it has 2 carbon atoms. So it will be carbon to carbon. I've added this single bond because all alkanes have a single bond. Alkanes consist of a single bond. So in drawing their displayed structure, you should also add a single bond. Now I have 2 carbon atoms and 6 hydrogen atoms. So these carbon atoms have been bonded to these hydrogen atoms. So it will be 1, 2, 3, 4, 5, 6. Hydrogen, 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 hydrogen. Now this is the displayed structure for ethane. Any questions so far, learners? You can leave that in the comments. Now we're going to draw our third one, which I'm going to use as my last example. On number 3 we have propane. Now since propane is on number 3, or it's the third compound under alkanes, it means that the value of N on my general formula will now represent 3, as propane is on number 3. So it will be carbon, where there's N, 3, hydrogen, the value of N, 3 plus 2. 2 times 3, 6. 6 plus 2, 8. Now, this is the molecular formula for propane. If I'm to draw the structure for propane, since propane has 3 carbon atoms, I'll first start by writing the 3 carbon atoms that will be bonded with a single bond. To be carbon to carbon to carbon. And here I have 8 hydrogen atoms. I'm going to add 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen, 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 hydrogen. This is the discrete structure of propane. Excuse. Now learners, let me give you the remaining 6. At your own free time, you can try. If you can manage, you can capture them and send them to me so that I can verify for you. Now, the fourth compound in the alkanes is butane. The fifth one is pentane. The sixth one is hexane. And the seventh one, heptane. The eighth one is octane. The one on number 9, it's nonane. And the one on number 10, decane. Now you can observe that all of these compounds end with ANE. ANE. So now learners, I said thank you for your time. I hope you understood anything. Now, like, share, follow, and comment next so that I can continue teaching this topic.